Good evening, everyone. We're going to go over the written exam. Now, the written exam had some tricky problems. I'm going to go over some of the easier ones. So just bear with me. We did the written exam for Module 1, which was over Chapter 1, Critical Thinking. And that involved Pascal's Triangle, Poyet's process, the problem-solving principles, and just being able to reason mathematically. I can get my PowerPoint to move. Okay, so problem number 1 was completing the following puzzles. And it was place 8, 10, 11, 12, and 13 into the circles to make the sums across and vertically equal 31. So what you're going to have to do is you're going to have to analyze your problem. I'm trying to get this to go back to writing. There we go. All right. So you have the numbers that you can use. 8, 10, 11, 12, and 13. And yeah, you're going to use these circles right here. And you had to make the sums across and vertically equal 31. Well, you know from the word sum, you're going to be using addition. So you're going to now plan it out. That could be just writing out all your options. You could have an equation. I'm just going to start writing. 8 plus 10, that's 18. Now, 31 minus 18, is going to give you 13. Now, 8, 10, 13. Now, 8 and 12 is going to give you 20. So the only thing you're missing is 11. Now you've used every single number with 8 twice, and that works with your circles. So you're going to have 8 here, 10, 13, 12, and 11. You're always going to, using Poyet's principles, you're going to want to recheck. So 8, 10, 18 plus 13, that equals 31. 11 and 8, 19 plus 12, again, 31. It works. Yay! Was there any other answer to solving this puzzle? I didn't find any. So to me, there was only one solution. For part B, it gave you the diagram, and it gave you the pattern. It was using addition. Each side was equal to the 2 circles near it. So 7 was 2 and 5. Then you had 10, 2 and 8, 11, 8, 3, 8, 5, and 3. So you're just going to go fill in the circles because if you looked at them, they were the same pattern. So 15 minus 7 would give you 8. 12 minus 7, that'd give you 5. 17 minus 5, that'd give you 12. Now, will 12 and 8 make 20? Yes. So you can do the other 3 on your own because they follow the same. On to the next. I can get this to work. Ooh. Let's erase everything because apparently that keeps moving on. This was Pascal's Triangle. And you're going to get from point A to point B and find out how many possible solutions there were to get there. only moving upwards and to the right. See that? So you can't move left. So all 3 boxes right here are obsolete. You're not going to go there. And what I found easiest was ignore the boxes as a whole. Use the lines. So you went up to, and I made dots. So dot. See? So we went to this one way, one way, one way. Same down here. One way, and one way. So now 1 plus 1, that equals 2. Now you have 2 and 1, that's going to give you 3. Same right here, is 3. 3 and 1, that's going to give you 4. 3 and 3, 6. 3 and 1 again, 4. Now you have 6 and 4, which is 10. Gonna do the same over here. And now you have 10 and 10, which will give you 20. So there were a possible of 20 ways to get to that point. From A to B. Now down here is a little bit different. You had arrows pointing which way you could go, and you couldn't differ from that. So which path can get you from C to E? If you follow the arrows, you're going to see C to A to B to E. See? But that's the only way that it can go, because A can't go to E. See? And B can't go down to F. So we're going to go down to the next path. So C, B, and E. No other ways. So then we're going to go down to next. C, F, E. But it can also go C, F, up to B, and then E. Now if you look, you can go C, F, D, but then D doesn't go to E, so you can't really go there. So there's 4 possible ways to get from C to E. So I'm going to erase this now. Zippity. Zippity, zippity. Bringing us to the last one that I want to talk about is problem 5. This is part of Polya's principles, but we're only really doing steps 2 and 4. That's the main focus of this. It's process of elimination. They're giving you a problem, you're going to analyze it, figure out which person goes with which wife, and then you're going to double check yourself. So 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Anne. Their husbands' names in just some order. They didn't give you with who it went with. David, Will, Gus, and Floyd. Now you're going to use the table. Floyd is Josie's brother. Just because we're in Arkansas doesn't mean we marry our brothers. So what we're going to do is so you're going to mark out Floyd on Josie's. Josie and Gus dated some, so they're not married. You're going to go Josie and Gus, mark him out. because then Gus met his present wife. Kitty is married to Will. See, there we go. Big old circle on Kitty and Will. But that means Kitty can't be married to David, to Floyd, or Gus. And Will can be married to any other woman as well. But look at that. 3 X's on Josie, that means Josie has to be married to David. But David can't be married to anyone else. Now we're just down to Anne, Sarah, Floyd, and Gus. Anne has 2 brothers. Well, if you look back up here, Floyd is Josie's brother. So he's not an only child. Which is part of the next one. Anne's husband is an only child. So Anne's husband can't be Floyd. Even really don't have anything to do with 2 brothers. Sorry. That means Anne is married to Gus. Mark that out. And Sarah is married to Floyd. See, process of elimination. Awesome. Thank you so much for watching. I hope you learned a lot from this. If you have any questions, seek out your nearest teacher and hopefully they can help you. Thank you.